highest level maths going over and explaining the factor theorem. So one of the first new AS pure maths topics that you'll learn in year 12 in roughly, okay, 136 seconds. Okay, let's go. So yeah, algebra and functions E4. So f of x is equal to x cubed minus x squared plus 4x minus 12. Part A. Show that x minus 2 is a factor of f of x. So the factor theorem states that f of x is equal to 0 if and only if x minus a is a factor. Okay, so learn this year for your A-level exam this year, guys. Okay, so if x minus 8 is a factor. In other words, if I sub in f of a, I will get 0. What? Okay, so in this case, if I sub in, okay, x is 2, then I'm going to get the following. So I'm going to get 2 cubed minus 2 squared plus 4 lots of 2, okay, minus 12. Now 2 cubed is 8, 2 squared is 4, so we've got 8 minus 4 plus 4 times 2, so 4 lots of 2, yeah, makes 8. Subtract 12. Okay, so here, yeah, we've got addition and subtraction. So use mid-mass here, so work from left to right. Okay, so 8 minus 4 is 4, plus 8 makes 12, minus 12, yeah, makes 0. Okay, therefore, x minus 2 is a factor. Okay, guys? So remember, yeah, so the key with this is that f of x is equal to 0 if and only if x minus a is a factor, i.e., if I substitute in x equals a, so yeah, if I have f of a, if that's equal to 0, then that's a factor of a cubic polynomial, yeah, of degree 3. Okay, but that's how, yeah, that's how the factor theorem actually works. Okay, so here, because x equals 2 is a root. Sorry guys, about my handwriting. Yeah, sorry about my handwriting there. Okay, so that's part A done. Okay, what about part B? Well, part B says hence or otherwise show that the equation only has one root. Okay, so show that f of x equals 0 only has one root. So I'm going to use polynomial division here to obviously work out the other quadratic part, and then show that the discriminant of the quadratic is less than 0. Hence, the quadratic here will not factorize and get me that. Okay, so let's work it out. Okay, we got x cubed minus x squared plus 4x minus 12. Okay, so I'm dividing that, guys, by x plus 3. Okay, so I'm doing long division here, or bust up here with algebra. Okay, so the key here is that I do x cubed divided by x, so that'll be x squared there. Then I do x squared times this, so I have x cubed minus 2x squared. Okay, I'm not going to subtract it. That's going to go to 0. And I have minus 6, we get minus 2x squared. So I'll be plus x squared. Again, yes, sorry, I haven't got much of a gap here. Okay, so I'm going to have to obviously go to the side here. I apologize about that, guys. I apologize about that. Okay, again, knock one off the power, so that'll be plus x. And I have plus x, lots of this. And I have x squared minus 2x. I'm going to subtract this. So I'm going to do this, subtract this. This will go to this go 4x minus 2x makes 6x. Okay, and then I'm going obviously drop down here the minus 12. So minus 12. Again, not one from the power. So I'm going to have plus 6. 6 lots of x minus 2 makes 6x minus 12. And then when I subtract that, guys, the remainder goes to 0. And again, apologies here for obviously being off the actual page. Okay, but I hope that makes sense. Okay, so hopefully you can see that this quadratic here doesn't actually factorize. But again, if in doubt, let's work out the discriminant. So b squared, yeah, minus 4ac, okay? So b is equal to 1, okay, remember, yeah, coefficient of x, a is equal to 1, and c is equal to 6. So we got 1 squared, subtract 4 lots of 1 times 6. Now, if you work this out, guys, you will get, yeah, you'll get 1 minus 24, which is less than 0, which means that the quadratic that I have that is left over has no real distinct solutions. Therefore, this cubic only has one real root. Okay. Now, those of you here that's looking at obviously A-level, yeah, for the maths here, recognize here that I have, yeah, what we call here 2 additional complex roots. But for the purpose here of A-level maths, okay, this cubic equation here or polynomial only has one distinct real root. Okay, but it has 2 complex roots. Okay, but that's beyond the scope of today's video. Yeah, if you're wondering, yeah, so this cubic here, it will have 2 complex roots and then 1 real root. Okay, thanks for watching. Take care. All the best.